sure most people already have some familiarity with the quadratic formula, but in case it was never taught to you or it's been a long time and you forgot what it was and how it worked, I'm going to go over it because it's such a vital tool when dealing with quadratic equations. There are going to be so many quadratic equations that we're not going to be able to solve using simple factoring or completing the square. And if you can't use a quadratic formula, then there are a lot of problems that you won't be able to solve. And from here on out, we are going to be dealing with quadratic equations quite a lot in this class and in pre-calculus and for quite a long time until they start dealing with higher and higher order equations. But for the next few courses, quadratic equations are going to be a big part of it, and therefore the quadratic formula is going to be very important. And I thought I'd also take time to go over the proof, as I'm aware a lot of people have trouble remembering it. And when I was in college algebra, I used it so much that I never really had trouble remembering it, but when I didn't use it for a long time, I kind of forgot. I didn't really forget, I don't know, it's just easy to just screw something up, just like if you forgot the C on the end or something like that. So what I'm going to do is I'm going to show the proof of the quadratic formula, which is if you can do it, you don't have to remember it. I don't have to remember it anymore. I just learned the proof of it, and then it wasn't too hard to derive if I ever forgot it. So anyways, here's the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. And what this formula does is it gives us the zeros of our function, of our quadratic function, and all of these come from the standard form of a quadratic equation. So we have f of x is equal to ax squared plus bx plus c. So we have the a, the b, and the c. So let's do an example problem. This formula looks a little bit complicated on the surface, but I assure you, once you've done this a couple of times, it's very easy to use. So let's say we have the equation 3x squared minus 5x plus 1 is equal to 0. And at first glance, some people might say, well, if we just divide out 3, we're going to get x squared minus 5/3 x plus 1/3 is equal to 0. But here we're stuck because we need two numbers that multiply to be 1/3 and that add to be 5/3. And I can't think of any. I don't think anyone else would either, off the top of their head anyways. And here, completing the square won't work. So what we need to do is use the quadratic formula. Actually, let's just leave this up here. So let's rewrite it. X is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. This is all included, 2a. So this is our a, this is our b, and this is our c. And all we have to do is just put our a, b, and c into our quadratic equation, figure out what that is, and then get our answer. So our b is minus 5. So This is a very careless mistake that most people make. They always forget about the minus sign number. That's one of the things I used to forget when I didn't use the quadratic formula for a long time. But there is a minus sign out there. So that's one thing to watch out for. Plus or minus the square root of minus 5 squared, minus 4a, which is 3, and c, which is 1. All over 2a, so 2 times 3. So now we just simplify this. Minus 5, that's 5, plus or minus the square root of minus 5 squared, which is 25. Minus 4 times 3 times 1, that's minus 12. Over 2 times 3, which is 6. So now this is equal to 5 plus or minus the square root of 13 over 6. So obviously it was a good idea to use quadratic formula, because I don't think most people over here would look at this and say, oh yeah, the factors are plus 5 plus or minus the square root of 13 over 6. I mean, that number doesn't really come to my mind right away. I would have definitely had to sit there for a long time before I thought of 5 plus or minus the square root of 13 over 6. So this means that our solutions are 5 plus the square root of 13 over 6 and 0, because this is an x-intercept. And then the other point is 5 minus the square root of 13 over 6. And sometimes you'll get a number like 6, you'll get a square root of 16, which you'll simplify to a 4, and then that'll be a very nice answer. But it won't always be like that, and if you get some answer like this, then don't be worried about it. That is the answer. Sometimes people get an answer like this and they think they did something wrong. Well, it's just sometimes the numbers don't work out that great. So now that we've seen how to use it, let's see where the quadratic formula comes from. And if you watch the other video on quadratic equations where we were looking for the equation that would give us the vertex of a quadratic equation, it's actually very similar, except in this one we continue on a little bit further. So we get the equation from the standard form, ax squared plus bx plus c. And the first thing we do is divide a out. Actually, let me do a different color. So the first thing we do is divide a out, so we get ax squared plus b over ax plus c over a. And we're solving for the zeros. Next, what we do is we complete the square for this term. Complete the square so we can solve for the x's. So let's complete the square. I'll write the little square completing term in a different color. So our square completing term, to complete the square we need to add b squared over 4a squared. And if you want to know where this term comes from, when we complete the square, in order to complete the square of anything, we have to take the b term and divide it by 2 and square it. And in this case, I'm not talking about b here. I am talking about that, but what I mean by the b term is this. This is the b term. We take the b, we divide it by 2, and we square it. So in this case, b is b over a. So if we take b over a and then divide it by 2, and division by 2 is the same as multiplication by 1/2. So this 2 ends up going underneath the b. And when we square this, b squared is b squared, 2 squared is 4, and a squared is a squared. So that's where that comes from. Then we still are adding our c over a. And in many cases what we do is, in order to balance out, because remember, if we add a term to our equation, we can add anything we want to our equation. but we have to add it to the other side of the equation. But instead of adding it to the other side of the equation, I'm just going to subtract it from the same side, because we're solving for the zero, so we don't want any stuff over there. And we change back to the other color. Or we could say we added it over there, then just subtract the term over. But either way, what we can clearly see is that our equation is still equal. We're adding a b squared over 4a squared, and we're also subtracting a b squared over 4a squared. So this entire equation is still equal. If I just added this, and then I didn't add this to the other side or subtract it from the same side, then the equation would not be equal anymore. So we've just completed the square, so now we can write this as x plus b over 2a squared plus c over a minus b squared over 4a squared is equal to 0. Now the next step is to get both of these terms over the same denominator, and I can accomplish that by multiplying the top and bottom by 4a squared. So if I multiply both the top and the bottom by 4a squared, then the total term is still going to be equal. So let's do that. So x plus b over 2a squared. So I've multiplied both top and bottom by 4a squared. So I get 4ac over 4a squared minus b squared over 4a squared. And now you notice that both of these terms have the same denominator. So we can combine them and just write them over one common denominator. So this is x plus 2a plus 4ac minus b squared over 4a squared. Now what I'm going to do is I'm going to subtract this entire term over to the other side. So x plus b over 2a squared is equal to minus 4a squared minus b squared 4a squared. Now I'm going to take the square root of both sides. So this will give me x plus b over 2a, and this is going to be plus or minus now. Remember, this is, since we're taking the square root, it can be plus or minus whatever this is. So minus 4ac minus b squared over 4a squared. Now, we don't have to get rid of this minus sign, but most of the formulas do, because we in general like positive numbers, and if we have a negative in a denominator, underneath a radical, then obviously that causes problems. However, it would still work out to be the same. But just for the niceness of it, what we do is we pull a minus 1 out of here. So if we pull a minus 1 out, we get x plus b over 2a is equal to plus or minus square root. So we pull a minus out. So if we pull a minus out, it's going to cancel out this minus sign. But what's going to happen is this 4ac is going to become negative, and this b squared is going to become positive. So we get positive b squared minus 4ac. So they've just switched around over 4a, and this includes the bottom. And now we can subtract this over to the other side. So we get x is equal to negative b over 2a plus or minus square root. I need to make the square root bigger. There we go. B squared minus 4ac over 4a squared. While we can't take the square root of this entire term, what we can do is eliminate 4a squared. We can take the square root of 4a squared and remove it from the radical, Because the square root of 4 is 2, and the square root of a squared is a. So that's what we do. We eliminate the bottom part from the radical, because we can. Minus b over 2a. So now we're only left with the numerator in the radicals, b squared minus 4ac. And we've taken the square root of the bottom part, so it is no longer part of the radical. So the square root of 4 is 2, and the square root of a squared is a. And this is plus or minus. But now you notice that we have the same denominator, so we can write these over the same fraction. So this leaves us with x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And this is our quadratic equation. Once you've worked through how to get it and just completing the square, it becomes very easy to reproduce this if you ever need to. Most of the time, though, you'll remember it when you're using it a lot, especially in these beginning college algebra courses and pre-calculus. You're going to be using it quite often. And in fact, I recommend anytime you're doing a formula to solve a problem to write it out every time so you remember it's ingrained in your memory. But should you ever forget it, I would take the time to figure out how it works. It's just a simple completing the square, and it's definitely saved me a couple of times for forgetting the C or the minus sign. I remember that was a thing I'd always forget if there was a minus sign and the B in the front. But it doesn't take very long to figure out how to learn, and it's I guess it's a nice little bit of math to know.